Welcome to the second tutorial BranchCAD, or Branch Distribution Networks Design part of the Water Systems package. Well, to start, we click on Water and Sanitation Design icon to access the menu of Water Systems. Let's click on Execute, which will run the program. On the left-hand side, we have a paint box where we can draw a diagram of the network to calculate. On the right-hand side, we have a table where we will enter the data corresponding to the network's branches. For example, I'm going to draw a branch which can be closed by double-clicking. On the table, you can see that the data concerning to every section and junction nodes which will be added to the table after the branches drawing have been closed. Branches taped to any node can also be drawn just by clicking on a point close to the node to tap, and automatically a section will be drawn. Continue drawing sections until the branch is being closed by doing a double click again. Using this procedure, we can add as many branches as needed for our project. This is only a demonstration of how to work the data entry through a scheme. When we have already defined the distribution network, we have to enter the survey data such as length of each section, the elevation of each one of the nodes, and the number of households that will be connected to each section, if any. At the top side of the screen, we have a box to define the desired residual pressure and the unitary flow in the nodes, which will depend on the chosen provision of water, rate population growth, period of design, and maximum hour consumption factor. To check this data, just double-click on the box. In this case, for example, we can check the factors that define the unitary flow, and of course, we can modify this information to meet our project conditions. As for the residual pressure, also double-click in this box and we will have access to the minimum pressure among other data such as the maximum static pressure, etc. To learn how the program works, we will use an existing project. Initially, we click on the Survey Book button and then on the Open Project button. With this, we will have access to the existing survey files using the statometric or tachymetric method. We open it and get the fully calculated survey book. We export by clicking on the corresponding button and get our network drawing on the paint box. To check the pressures, we will turn on the button to provide the contour lines to facilitate the location of the lowest point of the network. At the bottom of the screen, we will be provided with two important data information for the design. One of these data is the minimum and maximum static pressure that will be presented in the branch form in case of placing any brake pressure box. In addition, we will have the maximum pressure from the prior brake pressure box. In our example, we have the lowest point at the station 39. We can also notice that the point 18 is quite low. However, we are going to start the design on the basis of point 39. To do this, we click on the button corresponding to the brake pressure box, which will draw a box which changes its position from the node to node. This responds to node's motion button selection, but if we put in the free motion, the box will move along each section as you move the cursor. At the moment, we'll select the node's motion button and we start to look for a point where the maximum pressure, indicated on the bottom, doesn't exceed 50 meters of maximum pressure which has been previously specified. For example, at this point I have approximately 43 meters, so I click here and place a box. I continue doing the same thing on direction to the distribution tank. I move up, and at this point we are where I have 53 meters, although it's a little bit higher than 50 meters, we will place a box at this point. As a next step, I proceed with the branches that depart from the 18th station. The station 14 have 40 meters of static pressure. I place one more box at this point. I continue in the direction of the tank, and at this point I have 52 meters. Although it's a little higher than 50, I place another box at this point. Following in this direction of the distribution tank, and in this station I have 66 meters. Note that when the pressure is higher than the stipulated maximum pressure, this will be shown in red. In this station, the maximum pressure is 27, which is very low. Reason why I will look for an intermediate point by clicking on Free Motion button. By doing this, I move the cursor throughout the section until a point that gives a pressure close to 50 meters. For example, here I have approximately 50 meters. I click and place the last box at this point. With this, I have completed to place all the brake pressure boxes to comply with the established maximum static pressure. Take note that in the last column of the table we have to which network belongs each section, depending on each placed brake pressure box. Next, I write the project name. For this, I'll use Project 3. And then click on the button to calculate. The program will start to provide some warnings. For example, in this alert, the program indicates that the station 2 has 6.47 meters of residual pressure. Since this station is very close to the distribution tank, I will click on Accept. I will check each alert provided by the program. On the bottom of the screen, we can notice that there is a progress bar that shows the progress of each network calculations. Also, we are still receiving alerts. At the end of the calculations, the program automatically will provide the spreadsheet with the design of the basis of the parameters that the user has defined. The design provides the diameters which have been determined by the program using a database which can be modified by the user. This design respects the established residual pressure for each node. Beside the design diameters, the table presents the head losses by friction for each section, the speed in each section, the elevation of the hydraulic gradient, and the residual pressure for each node. To check the profiles, click on the Profiles tab, where we can check the residual pressures all along each section. To do this, we simply place the cursor near the branch to be checked, where a vertical line in red will be drawn. Additionally, the data stipulating the pressure will be provided at the bottom of the screen. With this, we have finished the design. Finally, we save the project. In addition, we can export our spreadsheet to Excel by clicking on Export to Excel button, where we write the file name. I'm going to use the same name of the project, which is example 3. Now let's find the Excel file in Path My Documents, Warter Systems-BranchCAD En Projects. Open this file where we can find the spreadsheet and the conditions in the notes. With this, we have completed our tutorial on BranchCAD. Thank you for your attention and until next time.